3F asks us to use transformations to sketch graphs. Verbally, I'm going to explain this more than I will actually on paper. You'll see as I do you'll see how I've done the question, but verbally I'll explain how we can use those transformations as we go. So this example is to find a sequence of transformations which takes the graph y equals 4 divided by x plus 5 minus 3 to the graph of y equals 1 on x. So we're going from a transformed graph to a base graph. Note that in the previous section, 3e, this is like example 1. So we're going to use this to sketch the graph of y equals 4 divided by x plus 5 minus 3, and we're going to state the equation of any asymptotes and the coordinates of the axis intercepts. First thing to note is that this equation or this function is an example of a hyperbola, so no square on the bottom means a hyperbola, not a truncus. So it's going to be something that starts at the top, finishes down here, and starts at the bottom and finishes down here. Alright, so it's going to be something like that. Now, first step, this is just like the previous examples where we're going to find those transformations. So we're going to rearrange the equations in order to transpose the terms outside of the brackets. So for instance, that -3 and the 4 needs to move across. So we're going to plus 3 and we're going to divide by 4, giving us this function here. This tells me what my x value is and my y value. So my x new value is x plus 5 and my y new is 1/4 y plus 3. Because we're going from our transformed to our original, we don't rearrange. So keeping going with this, our function is going to be, so first step's the translations, so the plus 5 and the plus 3, and then the dilation from the x-axis of 1/4. This gives me my x new and my y new, and this is where I can read my transformations fully. So I am going to do my translations, 5 units right and 3 units up, and then I'm going to do my dilation factor of 1/4 from the x-axis. That's step 1. Step 2 is then to sketch this, and we need some equations, and this is where our transformations help. Note that in our transformations we went right 5 units. What we're actually looking at sketching though is the original, not the final. So the final would be here, right? And if the transformation to get from my original graph, which is the transformed one, to 1 on x goes right 5, then left 5 is where my asymptote is. Okay, so it's almost the opposite of what we've just done. Just like where I said before, up 3, we're now going to go down 3, so our asymptote is here. So those are my two asymptotes, and I need to put equations to them, so x equals -5 and y equals -3. I then need some intercepts, so at x equals 0, y is going to be equal to -11/5, so -2.2-ish, okay, so down here approximately. Doesn't have to be exact, it just needs to be approximately in the right spot because we'll label it. The other one is our y-intercept, so at y equals 0, what does x equal? We can do a rearrangement and get out that x is going to be equal to -11 on 3, which is 3 2/3, and we can draw that in. Now, what we do know about a hyperbola is that there is I suppose a line of reflection through here, so there's symmetry, which means that if I've got these 2 points, I can also find approximately a point here and approximately a point here. This point relates to this one here. I've moved 3 units down, so -6, and I'm going to go across about 1 1/3, I believe it is, to get me to this point. I can do the same thing here, where I go across 5 units, so -10, and then down, well, I'm about, not far, I'm 4/5, I think, off this value here. So there's a small gap. Put some arrows onto it. Now this function did state to label, so I will put my labels in there, and my x-axis and my y-axis, and then this is now complete.